In 1998, something happened that should not have happened. Astronomers were measuring dying stars. Routine work. Technical. Predictable. They expected to confirm what physics had long suggested, that the universe, born in fire billions of years ago, was slowly losing momentum. Like a stone thrown upward, gravity should be pulling everything back. For decades, this was the story. The universe expands. Gravity slows it down. Eventually, maybe, everything collapses. It was elegant, clean, logical. Then the data came in, and the universe refused to behave. To understand the shock, we need to step back. In 1929, Edwin Hubble discovered that galaxies are moving away from us. Not randomly, systematically. The farther away a galaxy is, the faster it recedes. The universe is expanding. That discovery changed everything. It meant space itself was stretching. But there was always a question. How fast is it slowing? Because gravity never sleeps. Every galaxy pulls on every other galaxy. Every cluster tugs at its neighbors. So expansion should be decelerating. The only debate was how much. Would the universe expand forever? Or eventually collapse in a big crunch? By the 1990s, technology had improved enough to measure this properly. Two independent teams set out to answer the question. The Supernova Cosmology Project, the High-Z Supernova Search Team. Their tool was simple in principle. Type Ia supernova. These are exploding stars that shine with predictable brightness. Cosmic light bulbs. If you know how bright something truly is, and you measure how bright it appears, you can calculate its distance. This allowed astronomers to measure extremely distant galaxies. And by measuring their distance and speed, they could determine whether the universe's expansion was slowing down. It was careful, methodical science. No drama, no spectacle. Just light curves and redshift graphs. Then the results began to converge. The distant supernovae were dimmer than expected. Not slightly, significantly, which meant they were farther away than predicted, which meant something extraordinary. The expansion of the universe was not slowing down. It was speeding up. Pause there. Let that sink in. The expansion of the universe was not slowing down. Gravity, the force that binds galaxies, stars, planets, was losing the fight. Something else was stronger. Something invisible. Something no one had predicted. The universe was accelerating outward. This was not a small adjustment. It was a cosmic crisis. If expansion is accelerating, and most of the universe must be made of something we do not understand, something with repulsive gravity, a force that pushes space apart, they called it dark energy. Not because they understood it, but because they didn't. Dark energy does not emit light, does not interact normally, cannot be seen directly. Yet it appears to make up nearly 70% of the universe. Think about that. Everything we see, every star, every galaxy, every planet, every human being accounts for less than 5% of the cosmos. The rest is dark matter and dark energy. Unknown, invisible, dominant. The rest is dark matter and dark energy. When the findings were announced, many physicists were skeptical. Maybe the measurements were wrong. Maybe dust was dimming the supernova. Maybe calibration errors. But both teams had reached the same conclusion independently. The data refused to go away. But both teams had reached the same conclusion independently. In 2011, the leaders of the two teams were awarded the Nobel Prize in Physics. By then, the conclusion was unavoidable. The universe is not drifting toward a gentle slowdown. It is accelerating toward a distant, cold future. And that future is unsettling. If acceleration continues, galaxies will move farther apart. Eventually, distant galaxies will slip beyond our observable horizon. Future astronomers, billions of years from now, may look into the sky and see almost nothing. No evidence of a Big Bang, no visible neighboring galaxies, just darkness. A lonely island universe. In that future, Cosmology itself becomes impossible because the evidence will have disappeared. Dark energy is not just expanding space. It is erasing cosmic history. Dark energy is not just expanding space. There are theories. Some suggest dark energy is the energy of empty space itself, vacuum energy, quantum fluctuations woven into the fabric of reality. Others propose new fields, exotic particles, modifications to gravity. But every explanation raises deeper questions. Why is dark energy so weak, yet so dominant? Why did it begin to dominate only in recent cosmic history? Is it constant? Or will it change? Why is dark energy so weak, yet so dominant? There is even a possibility, remote but real, that acceleration could increase dramatically. In a scenario known as the Big Rip, galaxies would be torn apart, stars separated, planets ripped from orbits, eventually atoms themselves pulled apart. This is speculative, but not impossible. In a scenario known as the Big Rip, galaxies would be torn apart, stars separated, planets ripped from orbits, eventually atoms themselves pulled apart. The most unsettling part is this: we do not know what 70% of the universe is. Modern civilization can map the human genome, land probes on Mars, detect gravitational waves from colliding black holes. Yet the dominant component of the cosmos remains a placeholder term: dark energy, a name that means we do not know. In 1998, the universe did not become darker in a literal sense, but conceptually, it did. A simple, predictable fate was replaced with something strange, expanding faster, growing colder, becoming emptier. A simple, predictable fate was replaced with something strange. The night sky feels eternal, stable, comforting, but the data tells another story. We live in a universe that is not settling down. It is accelerating into the unknown, but the data tells another story. And for the first time in history, we are aware of it, not through myth, not through philosophy, but through the light of dying stars, measured, calculated, verified, the most powerful force in the universe. Cosmos is something we cannot see, cannot touch, cannot explain, and it is winning. That was the day the universe went dark, not because the stars disappeared, but because certainty did. That was the day the universe went dark.